Good evening, everyone, and welcome to the 2020 Virtual Grand Canyon Star Party. I'm Ranger Raider Lane, the National Park Service coordinator for the event. And for 30 years running, Grand Canyon has been celebrating our pristine night skies through this annual event we call the Grand Canyon Star Party. Now, ordinarily, we have hundreds of astronomers and invite thousands upon thousands of visitors to the park to enjoy 8 nights of some of the darkest, most pristine night skies in the United States. Each evening is kicked off with a special guest speaker in our theater, followed by telescope viewing, constellation tours, night sky photography workshops, and much, much more. Next year, Grand Canyon Star Party is June 5th through the 12th. So mark your calendars, and hopefully next year we can be on site to celebrate this event. But this year, we decided to bring you a taste of Grand Canyon Star Party in the virtual realm. We want to try to mirror how a night at Grand Canyon Star Party unfolds on site. So we were lucky to start each evening, June 13th through the 20th this year, with one of our special guest speakers who are all willing to share their talks online with us this year. And we're excited to bring you some of the wonders of the night sky into your homes with our virtual telescope viewing sessions that will premiere right after this program. So stay tuned for those. Before we introduce our special guest this evening, I just have to thank a couple of entities that work with the National Park Service to put on this incredible event. First, I want to thank the Grand Canyon Conservancy. They're the park's official nonprofit partner. Their current priorities are incredible. I mean, they're doing trail restoration. They are working on a Desert View Intertribal Heritage Site, which is an amazing project happening out at the Watchtower area. They fund research and education in the park, and of course, one of their top priorities is night sky preservation. So through the generous support of Grand Canyon Conservancy and the supporters, Grand Canyon National Park was able to inventory over the last couple years 5,000 lights in the park. We've retrofit or changed out over 1,500 of those lights to be night sky friendly, and we have plans to retrofit many, many more within the next few years. All this combined allowed us to become, in 2019, a certified international dark sky park. And that makes us one of the most complex, highly visited international dark sky parks in the world. Now, that very same year, the park was awarded the distinction of the International Dark Sky Park of the Year by the International Dark Sky Association. They're the nonprofit entity that certifies parks and communities as international dark sky places, among a whole bunch of other things that they do. Now, their mission is to preserve and protect the nighttime environment and heritage of our dark skies through environmentally responsible outdoor lighting. So we thank the International Dark Sky Association, their tremendous staff, and their amazing work, and we hope they keep it up. Finally, Grand Canyon's International Dark Sky Place of the Year could not have been achieved without the dedication, the passion, and the expertise of the Tucson Amateur Astronomy Association, our essential partner for putting on the Grand Canyon Star Party. Now, in our virtual Star Party following this presentation, please thank the astronomers in the chat room. They're going to be populating the chat room, answering questions, and they do this out of pure love of the night skies. And the National Park Service is really proud to partner with them in this incredible endeavor. So with that, I want to introduce tonight's special guest speaker. Tonight, we are really lucky to have Dean Regas. Dean is an American astronomer, a public speaker, an author, and a television host. He's most widely known as the co-host of the syndicated television show Stargazers, which airs daily on more than 100 PBS stations around the world. He has been the outreach astronomer for the Cincinnati Observatory since 2000, where he specializes in astronomy education and public speaking. Dean is the author of 3 books, Facts from Space, 100 Things to See in the Night Sky, and 100 Things to See in the Southern Night Sky. He's a contributing editor to Sky and Telescope magazine and a contributor to Astronomer magazine. He's been a frequent guest on Science Friday and Here and Now. And in 2017, he created a podcast for popular astronomy called Looking Up, which he co-hosts with Cincinnati Observatory Development Director Anna Heeman. Tonight, Dean will be presenting to us a tour of the universe, and we're really excited to have him. Dean, thanks for joining us tonight.
Hey, my pleasure, Raider. Thank you for having me. This is great. This is a great honor to be part of this. And of course, I'm very sad that I can't be there in person and seeing the great dark skies you have there at the Grand Canyon. I've been going to the Grand Canyon Star Party for 4 years before this. So
Yeah.
every year for the last 4 years. And it's just such a treat to see how many people you have there, how many amateur astronomers set up all their telescopes, the energy, the amount of expertise, and it's just one of the top-notch events that I go to every year. It's really incredible, and I cannot wait till 2021. Mark me down. I'd like to come back again. So because for me, I'm a city dweller. I live in Cincinnati, and so part of the experience of coming to the Grand Canyon is experiencing the night sky, seeing the stars like we don't see here in Cincinnati, and that's one thing that is such a great thing that you all are doing with the lighting there and getting it to be even darker, because to see the Milky Way from the Grand Canyon rim is just awesome. And so thanks for having me for this, and thanks for doing these online talks.
Yeah, you bet.
So, well, I'm going to dive on in here and tell you a little bit about myself, and then go into our main program today, which is Tour of the Universe. I'm going to fly you around and show you everything that there is in the entire universe. We're going to start from the Earth and then launch off into space and go on out into space. Now, let's see. For this part, I'm going to do a few things here, and we're going to go to this part first. So I want to show you a little bit about the observatory here first, and where I work. This is the Cincinnati Observatory, and let's pull, there we go. And so this is where I work. We're about 5 miles from downtown Cincinnati. So we have a lot of light pollution, but we also have a lot of people. So we get to have people come over, look through the telescopes there. We have one telescope that is the oldest in the country, 175 years old. It celebrated its 175th birthday back in April. And so I got to at least sing to the telescope, which is very surreal. But anyway, and then we have our newer telescope that was made in 1904. These are our two main instruments that are open to the general public, that people can look through the telescopes and see the wonders of space. And so I've been doing the subject for quite a while. I've been the astronomer there for 20 years. And I've written a few books, like Raider mentioned. One is Facts from Space. It has about 1,000 facts from around the universe. And we also have 100 Things to See in the Night Sky. This is showing you how to find stars and constellations and planets and some deep space objects that you could find with minimal equipment and a lot of things with the naked eye. And I have a new version of this coming out in mid-June. So this is exciting. It's going to be expanded with more charts, with more visuals. So look for that. It's 100 Things to See in the Night Sky expanded edition. So I can't wait to see that one come out. And then the podcast that I do is called Looking Up. So this is, if you like podcasts, this is a great one to get you interested in astronomy. We talk about the topics of the day and interview some interesting guests too. So one of our more recent ones we had was William Shatner, and we interview astronauts and all sorts of things. So check that out. But on to my main topic today is we're going to do a tour of the universe, and we're going to fly around and see everything. We're going to go back to this perspective where we can see kind of just where you are in the universe and, well, a little bit more of just the vastness of everything. All right, so now I'm going to switch to a program called Mitaka that will show us our way around the universe, and we'll go on over there. There we go. And so this is a program where we're going to start on the Earth and launch off of the Earth and go out into space and see what there is. So hold on to your seats. Here we go as we blast off of the Earth. We're going up above our planet and turn around to see the world we live in. We start in Japan because it's a Japanese program, but we can go anywhere we want around the world. I can just click and drag and we can see different parts of the globe. We can look down on the North Pole. We can see the daytime versus the nighttime. We can see that the sun is on the other side here and lighting up the far side of the Earth. And when we're facing away from the sun, it's nighttime. So program is really powerful that we can go anywhere we want, but I can also move our time forward. I can go forward and backwards in time. So I can make the time go forward and watch the Earth rotate. And if we're ever getting lost in time, you can always keep track. Your time's there at the bottom. And so yeah, we started back in the past, but we're going quickly to the future here. And as we're going to look around here, we can see day versus night. But the big thing we want to do is now get off of the Earth. And when we leave the Earth behind, we're going to go out to the far reaches of space and making some stops along the way. And so as we go out to our stop number 1, we can see the moon. Now look at the distance between the two objects here. This is the scale distance. If the Earth was that big, the moon would be a little speck there, and that's the distance between them. In miles, we're talking 240,000 miles, or a 3-day rocket journey for Neil Armstrong, Buzz Aldrin, and company. That's how long it took them to get there. And so the moon is moving around the Earth, and I can move our time forward a little bit faster. And we can have the moon circle around the Earth. So there's the moon revolving around us. All the while, the Earth is spinning very fast there. And it takes 1 whole month for the moon to go around us. So we just went forward in the future. We're now in July. Let's move on to August. And so we went a few months in the future here to see what all is happening. Now, so this is the farthest any human has gone. Neil Armstrong and Buzz Aldrin and 10 other people walked on the surface of the moon. And but if we want to go to the next level, we want to go to somewhere even farther away. Let's back it on up. And now we're going to leave the Earth and the moon system behind. And when we do that, we can start to see the curve of the Earth's orbit. This is the Earth's path around the sun. And so now we're getting to see that along with a few of the other planetary orbits. We have Mars right here. We have Venus there. We have Mercury there. And we have the sun there. And so I'm going to center on the sun now. And we also have another circle here, Ryugu. This is an asteroid that's going around the sun that has a spacecraft visiting it. So that's labeled there. And the other thing you can see is there's a red circle. This is a distance marker, 1 astronomical unit. That's the distance, the average distance from the sun to the Earth. So that's, we'll just say that's 93 million miles, or 1 astronomical unit. So we're out here pretty far. We can't even see the moon here anymore. It's just the Earth and the planets and then the sun there. And let's get the planets moving. I'm going to move forward 1 day at a time. And now we can watch the planets circle around the sun. There they go. And so all the planets are circling around the sun in the same direction, but not in the same speed. So the closer you are to the sun, the faster you go. The farther you are from the sun, the slower you go. And so Mercury goes around the sun in 88 days, while it takes us a whole 365 days to go around. Now, out of all these planets, if we wanted to go visit one, Venus is the closest, but definitely not the place you would want to hang out, because the temperature on Venus is 900 degrees Fahrenheit. So you would melt into a pile of goop. So, you know, going there and dying instantly doesn't sound very good to me. Mercury is not much better. It'd be about 800 degrees on the daytime side. If you land on the nighttime side, well, it's 200 below zero. Yeah, that's not great either. And plus, you'd be bombarded by all the radiation of the sun. So again, you die pretty instantly. So that leaves us with Mars, and Mars is, it's not still ideal for us. It's still, there's not enough oxygen, not enough air, not enough water, very, very cold, but we could get by all that. We could figure out a way to send people to Mars, and the distance is the problem. To get from there to there would take you about 7 months. So 3 days to go to the moon, but 7 months to go to Mars. And by the time you get to Mars, well, Earth is going to be on the other side of the solar system. So you have to wait on Mars for 1 year until Earth catches back up again. Whew, boy, I don't know if going to the moon and back sounds all right, but to go to Mars and back and you'd be gone 2 years, I don't know. I don't know. If any takers out there, any volunteers would like to go to Mars, let me know. Because I think we'll do it. It's just a matter of time to get people to get there safely and back. Well, we've gone in the future here quite a ways, but we haven't gone very far in space. We've only gone out to Mars, but let's back it up. And between Mars and Jupiter, this is where most of the asteroids live. So these are the asteroids that are all circling around the sun also. And we can see them moving around here too. So far, astronomers have found over 700,000 asteroids that are all going around the sun. How they keep track of them, I don't know, but here's a bunch of them at least. We've been looking at this from the top, but if we look at it from the side, then we can get a little better perspective of how our solar system is very flat. It's like a flat disk. And so most of the planets and objects grow around this disk. This is the leftover remnants of our nebula that we formed from. All the planets and all the other things came from this spinning cloud of gas and dust. And so that spinning is still going on there. Oh, there is one person diagonal, if you noticed, going through across here diagonally. That's Pluto there, and we'll get to Pluto soon enough, so don't worry. Now we back up here some more. We're out to the gas giant planets. So we have Jupiter, we have Saturn, we have Uranus, and we have Neptune. I'll do a little close-up on Saturn here just because, well, no other reason than it's just really, really awesome looking. Saturn is my favorite planet, and with this program, we can see all of its moons, up to 82 moons, and then we have the inner moons, and then the planet and the rings themselves. And so I'll twist it around here so we can see the top down of the rings. And this has to be one of the most gorgeous things to see in a telescope. And so hopefully we'll be able to catch it next summer out there at the Grand Canyon and see Saturn up there and through the scopes. I think we're gonna have to stay up kind of late. Ooh, that's a good excuse for us to stay up later to see Saturn up in the sky. But it is really amazing to see in a telescope. And so the best viewing for Saturn this year is going to be right around after August, about August 1st, end of July, August, September, and October. Those would be the best months to see Saturn in the nighttime sky. But let's back it on up here. We still have got a long way to go. We've got to go out to Uranus and Neptune. And then after Neptune, it gets a little complicated. We're getting to this region where there's lots of other things out here, lots of other dots that we've discovered, with Pluto being one of them. Now, Pluto used to be a planet because it went around the sun, and here it is going around the sun, but I have to go 1 year at a time. That's how fast I'm moving time. Look at the clock go down there. We're already in the 23rd century. And so all these objects are going around the sun, but Pluto was a planet because, well, it was found when they didn't know about this other stuff. But as time went on and better telescopes came online, we were able to see there's lots of other things that go around the sun. You can see all those other little dots circling around like fireflies. Those are all Plutoids or Pluto-like objects, and Pluto is just one of those. Not exactly like a planet. But it is a very cool world with 5 moons, and we went by with a spacecraft that flew there. The travel time from Earth to Pluto is about 9.5 years. So that's the travel time we're looking at from there to there. But Pluto is by no means the farthest thing from our sun in our solar system. We have this object named Sedna that's way out here. We're 100 times farther away from the sun now. And Sedna circles around the sun in this very long looping orbit that goes out almost 1,000 AUs. To see it moving forward in time, I need to go 100 years at a time, and we can watch Sedna circle around the sun, going slowly when it's far away and then faster when it's closer. All in all, it takes about 12,000 years to go around the sun. So that is one weird object out there. But wait, there's more. When we back up some more, we can see a place where long period comets live. Comets that have long looping orbits that go around the sun. And some of these comets can go all the way out to 1 light year, the distance light travels in a year. And so there it is. This is about 6 trillion miles or 10 trillion kilometers from there to there. And so this circle, this is our solar system. Everything in here circles around the sun. And that includes all these comets, Plutoids, planets, asteroids, all that circles around our sun, the one star in our solar system. Let's zoom on in. Let's see this one star in our solar system. Here's our sun. And so this is the star that you see up during the daytime and nice and bright. But if we want to see the stars at nighttime, Well, and we want to get close to them, we have to go a long, long way. So let's back it on up here. We'll leave our solar system behind, and then we're going to go among the stars. And to get among the stars, you can maybe even see a couple stars at the top that look familiar in a nice little pattern up there. What does that look like? It looks like a Big Dipper to me. So there's the Big Dipper way in the distance, way past our solar system. And so our next star that we're going to see is not a Big Dipper star, but it's the star over here called Alpha Centauri. And Alpha Centauri is not like our sun. It's not like one star. It's actually 3 stars that circle each other. 2 yellow ones that are about the size of our sun, a little bit bigger, and they circle each other. And then there's one little red one that circles the 2. So you'd have 3 suns in your sky if you lived there, which would be very weird because maybe it never even gets dark. But this is our closest star system to ours. But it's not close. Remember, space is really big. And so on this scale, we're talking, this is 25 trillion miles from there to there. 25 trillion miles. Now, I have a lot of miles on my car, but I don't have anywhere close to that. And if you wanted to fly from Earth to Alpha Centauri to see the triple sunset, it would take you a little while. It would take you about 70,000 years to get there. That's with our fastest spacecraft. If you were walking, it would take you a lot longer, I would think. But 70,000 years in a rocket, yeah, you would not make that trip. That is for sure. Now, these other stars are much, much, much farther away. And so when we back up here, we can see these other stars that we can see at night here in the northern hemisphere, like Sirius and Procyon and Denebula and Arcturus and Fomalhaut and Vega. And now we're out to 100 light years. And we got to remember, these stars are all around us. So we got to think in 3 dimensions here. These stars are in all directions around us. And we can back up a little farther to see the Pleiades, Canopus, Spica, Antares, Betelgeuse. And now we're out at 1,000 light years. And this is kind of all the stars, all the big stars you see at night. And now we're starting to get into big territory, I hope. I hope you're starting to feel the gravity of all this, the astronomical scale of this. We started on the Earth and saw the Earth and the Moon, and that looked far. But now we're we're among the stars. But we have to go to the next level. And the next level is all these stars you see at night are one tiny part of one arm of our Milky Way galaxy. And so there is our galaxy that we live in. And what we're looking at is about 300 billion stars, 300 billion suns, all with a center of gravity around the center core here. And so the sun, our sun, is just that one star out of all these 300 billion in this flattened pinwheel shape galaxy. And if you notice, we're not even in the center of the galaxy. We're out here towards the edge. We're about 2/3 out from the center, which is probably good because in the center, stuff gets really complicated. The stars are jam-packed together. They're much closer together. We got to get break through here. Break through. And now, at the very heart of our galaxy lies a deep, dark, mysterious object of incredible density that anything that falls in disappears. And it warps the space and time around it. It is the black hole at the center of the galaxy. And this is what we think it looks like. We don't have an actual picture of the black hole, but we can see stuff around the black hole. We can see stuff near it. But right now, the only picture of a black hole we have is the one that's in an even bigger galaxy called M87. That was, maybe you saw that picture of a black hole taken about 1.5 years ago. But we're working on this one. We know it's there because stuff is circling around there. What happens when you fall into a black hole? I don't know. You're in big trouble, that's for sure, because you're not coming back out. Not even light can escape out of this. And so the good news is this black hole is very far away from us. We have these stars that are circling nearby, which are in trouble. They're pretty close. But we're at such a safe distance that this is never going to affect the Earth. It's not going to swallow up the Earth or the sun or anything like that. I mean, we can't even fly there if we wanted to. It's so far away. But we can watch it from afar, which is really pretty amazing. All right, so let's just take a breath here for a second because we've just come a very long way. We started on the Earth. We saw the Earth and the moon together. We saw the Earth going around the sun. We saw all the planets. We saw the asteroids. We saw the Plutoids. We saw the stars that are nearby us. Then we saw our galaxy. So outside of our galaxy, we have lots of other galaxies. And you can see some little ones here. The Large Magellanic Cloud, Small Magellanic Cloud, Leo 1, Leo 2, Sculptor Dwarf. These are all dwarf galaxies. We do have a major galaxy out here too. That was one we saw earlier, the Andromeda Galaxy. So this is another galaxy like ours with probably more stars, maybe closer to the order of 1 trillion stars. And this is so far away that you can't even really see it without a telescope. From the Grand Canyon, you could see it, that's for sure, because it's dark enough there. But from where I live in the city, I need a telescope just to be able to see it. And then we also have Triangulum, another galaxy. It's got about 40 billion stars in it. So those are our 3 big galaxies, Triangulum, Andromeda, and the Milky Way, at least in our neighborhood. And so we have to go back one more step. This is our final journey in our tour of the universe. We're going to back up all the way and see how many galaxies we have, because at this scale, every dot in the background, look at every dot in the background, each one of those is not a star. Each one of those is a galaxy of billions and billions of stars in it. And these are just the galaxies we've charted. Each one of these dots represents a galaxy that has been seen and photographed and numbered. UGC 6456 and NGC 4168. Not very creative names, I understand. But these are all galaxies. And so as we back up, we can kind of get an idea of how many galaxies we have in our universe. And so here we go, backing it on up, and let's see how many we have found. And that is the universe. Whew, okay, wow. So that's a lot. That's a lot to wrap your head around, isn't it? I mean, what we're looking at is it's mind-blowing. It's our map of everything that we have seen before. Now, you might have noticed a few things with the galaxies in here. So each one of these is a galaxy that we've seen. Now, our map is not complete, not by a long shot. You might have noticed the shape here as I was backing up. It has this butterfly shape to it. And this is caused by a few things. One is that our galaxy, the plane of our Milky Way, is right through here. So all those stars are in our way. So we can't look through those billions and billions of stars like a forest full of trees. So that's blocking our view that way. The other holes in the map are because they ran out of money. So we'll get some more money. We'll fill in these spots. Then we'll be able to figure out how to look through stars, which surprisingly they're already figuring out. I don't know how they do it. I don't know how you look through stars, but they're figuring it out. And then we'll get the whole sample. But if this is a good sample size of the entire sphere here, we're looking at about 2 trillion galaxies, each with billions of stars in it. And that is just incredible. This colorful stuff at the very edge here, this is not really colorful stuff. We're adding color to it to bring it out. What this is called is the cosmic microwave background radiation, the leftover heat of the creation of the universe. This is the farthest stuff that we can detect with telescopes. So we're picking up this energy that's at the very edge of the universe. This is the first parts of the Big Bang, essentially, that we're seeing, because when we look in space, we're also looking back in time. So the farther back in space we look, the farther in history we look. And so this is just what our map looks like of what the universe, well, what the universe looks like from where we are. What's outside of this circle? Nobody knows. Nobody can tell what's outside this. Could there be other universes? Could there be multiple universes? Could there be infinite universes? There certainly could be, but this is the one that we know about. And if we ever find one, you better believe I'll put it on the map, and then we'll include it. But right now we have our one universe, which is pretty big as it is. All right, well, it's also getting kind of cold out here at the edge of the universe. So what I'm going to do is I'm going to take us back home. I'm going to target the Earth, and I'm going to fly us home really fast. And I know some of you might criticize this, that you say, Dean, there's no sound in outer space. But I'm going to use sound effects, if you don't mind, if we fly back home. So here we go. Hold on to your seats. And we're back to the Earth and the moon and the moon. So we flew to the edge of the universe, got you back home to the Earth. Oh boy, look at our date at the bottom. August 3rd, 36,282. Ooh, I went a little long with my talk, Raider. I'm sorry. It's I know you said 30 minutes, but I guess I went about a couple tens of thousands of years too long. So I'm sorry about that, everybody. Hopefully you can get that time back. I can always go backwards. We always reverse the time. That's too much. You're getting dizzy. But I hope you enjoyed our tour of the universe, flying out to the edge and back. It's good to see the Earth still there. That's good news. I'm happy to see that. But I hope you enjoyed our tour of the universe here. And oh wait, I was going to do one other thing real quick. Because I know you guys are going to be getting some great virtual stargazing coming in here too. But this program is really amazing that you can download and get it. So just do a Google search for Mitaka, spelled Mitaka, and you can download it to your PC. There's lots of different versions, and then you can fly around and do this all yourself. It's really incredible. You can click on anything you want. And so this is, just the scale of the universe is just mind-boggling. And I know it makes you feel a little tiny, but it's what makes it better for me is that here I am, a teeny tiny creature in the universe, but I'm part of a team of people that are discovering things in the universe, that are making maps of everything, and that we can put it on a computer and show it to you, and you can expand your minds and your imaginations. It's just very inspiring to me. And so this is why I love this field. This is why I love doing this stuff. And so thanks so much for having me join you here today and taking our tour of the universe.
Well, thanks so much, Dean. I mean, space is big, and really there's nothing like going to Grand Canyon and being underneath such an immense sky. It really does bring you this type of perspective that Dean was just alluding to. And we hope to be able to see all of you next year on site, fingers crossed, June 5th through the 12th, 2021, for the next Grand Canyon Star Party. Hopefully we'll be able to see Dean out there on site as well, so you can ask him questions and share the incredible night sky with him. He usually gives constellation programs as well when he comes on site. Those are immensely popular, so we're really hoping that next year everybody will be able to be on site. And with that, please everybody stay tuned for the virtual telescope session, the virtual star party, if you will. That's going to premiere right when we end this here. So Dean, thank you so much for your presentation, and we hope to see you next year.
My pleasure. Thanks, Raider, and take care, everybody. Keep looking up.